Hey everybody, today we're going to be starting our Solving Systems of Equations unit. This is Chapter 6 and it is Lesson 1. Solving Systems of Linear Equations. Two or more equations are a system of linear equations. So check it out. I have a system because there's 1 and 2. I could have 3, I could have 4, but if I have them, then they, 2 or more, then I know that I have a system of equations. Solutions of systems of equations. A solution for this problem here with multiple equations is any ordered pair that looks like x, y, an xy term that is true for both or all equations in the system. Solving systems by graphing. This one I think is probably the easy. I think that this is an easy way. There are lots of easy ways to do it. Let's go ahead and do it by graphing today. Let's see. Well, we have a nice purple color for the black. Why don't we go with the purplish blue? So I need to go ahead and graph this. My slope here is 1, which means 1 over 1. But first I need to graph the, let's start out with the y-intercept. I know that it's going to be at 0, 2 is one of the points in this line. So I'm going to come up here, and this is where one of those points are, and then my slope is 1 over 1, so I'm going to go 1, 1. And that is going to give me this line. I have to be careful when I am drawing this because I will not be able to solve it if I don't get the line pretty close to accurate. Then at -2, 0 is where the next line, let's use a different color for this. -2, it crosses right here. And it looks like it's 3 over 1, so I'm going to go I'm going to go up 3, 1, 2, 3, and 1. So that means that I should have another point over here because 1 and then down 3. We'll put it there. Just going to make sure because I want this to be accurate, otherwise it will not line up. Looks like I got one right there. So alrighty. Remember, a solution is a point that is true for all of them. Notice where the two lines intersect. It looks like it intersects right here. What is that coordinate plane? Let's go over 2, or let's go over until we find it, the whatever this line is, this x term looks like it's a 2. And we're going up 1, 2, 3, 4. Oh, it looks like it's a 4. And that is the answer to the problem. 2, 4 solves both of the equations. This solves the system of equations. Now, the book actually says that you should go ahead and plop these numbers into the equations just to double check and make sure. And that doesn't hurt. Let's go out. Let me show you what that looks like. So if I put in a 2 for here for the x, and I put in a 4 here for the y, does it make it true? Is 2 plus 2 4? Yes. Let's do the same thing for 2, 4 and see if it works out here. If I put in a 2 here, will the end answer be 4? 3 times 2 is 6, minus 2 is 4. So that means that this side would be 4 and that side would be 4. Boom, that is a true statement as well. Yes. That works. Anomalies. Anomalies are, there are certain situations where you have infinite solutions and certain situations where there are no solutions. The infinite solutions happens when the two lines are the same. And the no solutions happens when the lines are parallel. So let's go ahead and get everything into its right form. Remember, you must have it in slope-intercept form in order to be able to graph it. So I'm going to subtract this x and move it to the other side. Subtracting, if I add an x here, that makes this 0, and then it'll put x on that side. So I would have 2y equals x plus 2. Got to get rid of this 2. And then I'll put a 2 here, or a 1 over 2. And it'll put and it'll divide this guy here by 2 as well, which will make this 2, which will make this 2 divided by 2 equals 1. So we have 1/2 x equals y. So let's go ahead and graph this 1 here. So I would find, it looks like it crosses the y-intercept at 1. And my rise is 1 over 2. All right, now we've graphed this one. Oh, look at the second one. It's like the same thing. I could graph it at 1, and I would go 1 over 2. It is the same exact line. So if I were to grab my pencil and graph it in a different color, it would look something like this, right? All of the solutions are going to be true. Anytime I plop in any number, all of those are going, all of the ones on this line are going to be true. There's an infinite number of solutions that will be true for both of these. That would be one anomaly, is when it's the same line. Let's check out this one and what happens here. So if I were to graph this guy, oh, it's nice that these are already in slope-intercept form. 2 is right here. And it looks like I have 2 over 1 for the slope, so I'm going to go rise is 2 over 1. And I can assume that this down here is going to be true just by that running the slope. I can kind of see where it goes. Okay, now -1, I'm going to find the -1 here. And it looks like it has the same slope of 2. So we're going to go ahead and go right there. You'll notice that the resulting lines never cross each other. If the lines are parallel, which in this case they are parallel, they will never cross each other, so there are no solutions that will be true for this one and true for this one at the same time. So you'd have to write no. You could actually write out solutions. I would just write no. And then for this one, you would write down infinite. And that is it. we have a little practice to do with this. I want you to go ahead and do your best and get after it.